Okay, so what we have here is an absolute value rational inequality. Oh, this is going to be a real doozy here because there's just a lot going on. But again, let's break it down into what we have. It's an absolute value, so it's going to be separated into two problems. Okay, those problems, how we separate that is going to depend, again, because this is an inequality, on the greater than or less than. So this is greater than, so this is an or situation. And then we're going to see that when we break them down, we're going to end up with rational inequalities, and we'll have to remember how we did that. Okay, so let's see. So the first thing we have is we have x plus 3 over x minus 2 greater than 3. So that's as it is without the absolute values. Or we get x plus 3 over x minus 2, switch to less than, switch to negative 3. So absolute value, x plus 3 over x minus 2 is either greater than 3 or x plus 3 over x minus 2 is less than negative 3. Now we have two rational inequalities that have to be solved, so we have to remember how to do that. So that was all about comparing to 0 and making that chart. So I would have to do, subtract that 3 over so that I'm comparing to 0. I'd have to go and get a common denominator, which would have to be x minus 2. So I'd get x plus 3 over x minus 2 minus, and then 3 would need an x minus 2 over x minus 2 greater than 0. All right, now if I go ahead and simplify that and put that all over x minus 2, now I'm going to have to skip some parts of this, but let me just explain it in words. All right, I have x minus 3x on top there, so that's negative 2x. And then I have 3 minus 3 times negative 2. So that's 3 plus 6. So that gives me plus 9. All right, so I get that. Okay, so now once I've done that with a rational inequality, if you remember, now I have to figure out when the numerator and denominator are 0. So this numerator is going to be 0 at 9/2, and this denominator is going to be 0 at 2. So those are the numbers that have to go on my number line chart. So that's going to be, what do we say, 2 and 9/2. So 9/2 is 4.5. So let's see, let me put 2 and then 9/2 over here. All right, so this is where we're going to split it. So now I need some test numbers, test values in each region. I could use 1 over there. Between 2 and 9/2, I could use 3. And bigger than 9/2, I could use 5. Okay, so when I go in now, when I plug in 1 back here, I want to figure out whether it's going to be positive or negative. So negative 2 plus 9, that's a positive. And when I do 1 minus 2, that's a negative. And so overall, I get a negative for that region. In here, if I use my test value of 3, if I plug that in, negative 6 plus 9, that's a positive. 3 minus 2 is a positive, so I'll get positive in that region. I'm doing the same for 5, negative 10 plus 9, that would give me a negative. 5 minus 2 would give me a positive, and so that's negative. Now remember, I go back and I decide, what did I want? I want it greater than 0, so I only want positive. Here's where it's positive. So the solution from this part is 2 to 9/2. All right, just this region from over here. So that's part of my solution. Now I have to go redo the whole thing over here on the right with my other inequality. So I'm going to skip some steps in here so we can get to the solution. All right, so what I would have to do is, again, bring over, so this time add over 3 and compare to 0. But now, so if I go ahead and get a common denominator and simplify that, you should see, you should get to 4x minus 3 over x minus 2 less than 0. Okay, I skipped some steps in there, but that's what you should end up with. Now, that means that my numerator will be 0 when x is 3/4, and my denominator will be 0 when x is 2. So I go ahead and chart. I would need 3/4 and 2. And that's where I'm going to split. So less than 3/4, I could use 0 in there. Between 3/4 and 2, I could use 1. And bigger than 2, I use 3. All right, so if I put 0, again, now we're going back in here. If I put 0 in there, I get a minus. I get minus 3 over a minus. So I get positive there. If I go and do 1 and plug it in, I'll get a positive over a negative. So I'll get a negative in there. If I put 3 in, I'll get a positive over a positive. Get positive there. Now we go back. What did we want? We wanted less than 0. We wanted anywhere it's negative. Oh, that's in here. So that would be between 3/4 and 2. Okay, so now I have to give the final solution to this. Let me get myself a little more room here. All right, so basically my final solution is both of these together. Now those are two separate regions. We have the 3/4 to 2 coming before the 2 to 9/2. So 3/4 less than x less than 2, or 2 less than x less than 9/2. That's in inequality. In interval notation, we would have 3/4 to 2 union 2 to 9/2. And then a graph of the solution. Remember, those other things were just helper graphs. We would have 3/4, 2, and 9/2. Again, this is going to look a little strange because the only place these don't meet up is 2. So we have open here, open at 2, everything in between. And then we don't have 2, but then we have 2 open to 9/2 open. Okay, so if you like the other notation, would be like that. So that's quite an involved problem. All right, we're not going to do a lot of those, but it does show you what would go into doing an absolute value rational inequality. It does give you a good review of doing two separate rational inequalities. So that's that problem.